Good day wherever you are. I want to welcome you to this lesson. Today we want to look at this question. You are provided with 0.1 molar sodium hydroxide. So this was supposed to be capital M. So that is 0.1 capital M. Solution G made by dissolving 23.46 grams of a diabasic acid, this in 250 centimeters cube of distilled water. So this mass was dissolved in 250. Very important to note that this mass prepared a volume of 250 centimeters cube. You are required to dilute solution G, standardized diluted solution H using the sodium hydroxide solution F. Determine the mass of M in the formula H2MO6. Procedure. Using a measuring cylinder, measure 20 centimeters cube of solution G and transfer it into a beaker. Measure 80 centimeters cube of distilled water and add it to the 20 centimeters cube of solution G in the beaker. Label this solution H. Procedure 2. Place solution H in the burette. Pipette 25 centimeters cube of solution F into a 250 centimeters cube conical flask. Add 2 to 3 drops of phenolphthalein indicator and titrate with solution H. Record your results in the table below. So we have been given the volume that was used, that is the first iteration, the second and the third one. So we will only fill the table using the initial 0.0. And then we will do the arithmetic, that is 14.1, 13.9, and then 14.2. I want us first to understand what is happening in procedure 1 and procedure 2, because if you don't understand that, then definitely you are not going to calculate the whatever you are going to calculate downwards. What is happening in procedure 1? We are taking 20 centimeters cube of solution G. Dilute it by adding 80 centimeters cube of distilled water. Now we prepare 100 centimeters cube of solution H. So what is the relationship between G and H? So G and H are one and the same thing. It is an acid. It is acid what? Acid, it is the diabasic acid H2MO6. It is that one. The only difference is that H has been diluted. So the concentration for H is different. The concentration of G is different. But the number of moles in 20 centimeters cube of the original solution C will be equal to the number of moles in 100 centimeters cube solution H. Note that. Let me repeat that once again. Maybe you didn't get it. You didn't get it. 20 centimeters cube of solution G has got a given number of moles. That same number of moles will be equal, this moles in 20 centimeters cube solution G will be equal to the number of moles in 100 centimeters cube of solution H. The number of moles will remain the same while concentration will change. Thank you. Now you understand that we have solution H in our burette. This is an acid which is going to react with F, because we know F is a sodium hydroxide. F is sodium, so it is a base plus an acid. These are the information which you must understand before you begin. Calculate the average volume of solution H used. H. Now H, this is the solution, the volume of H that was used. So we get the average 14.1, 13.9 plus 14.2, we divide by 3, we get the average as 14.07 centimeters cube. That is the average. Okay, now we want to determine the number of moles of solution F in 25 centimeters cube. So solution F, but we know what we have solution F. Solution F 0.1 molar, meaning that this is the number of moles in 1 liter in 1000 centimeters cube. So we will get this one, we will say 0.1 capital M means that 0.1 is the number of moles which are contained in 1000 centimeters cube solution F. So what will 25 centimeters cube solution F contain? It is 25 times 0.1 divided by 1000, which will give you 0.0025 moles. Determine the number of moles of the acid in solution H in the average volume. Now, this one, we don't have much information about it, but we will use the reaction between H and the F, and then we will be able to get the, the number of moles. H has reacted with F to form products. So let us see, what is H? H is an acid. We have H, which is this one. The only difference, it is G which has been diluted, so the formula remains the same. So H, it is H2MO6 plus F, which is sodium hydroxide. Because this one is a diabasic acid like sulfuric acid, so therefore it will form sodium, that is salt, MO6 plus water. So the most important thing here is the balancing. So this one we'll put it to here. So that tells you the ratio of the acid and the base is 1 to 2. But we have the number of moles of the base F. We have the number of moles of F, which is this that reacted. So if 2 is 0.025, what will be 1? So it means that moles of H in the volume used equal to a half times the moles of this, a half, 0.0025, which is equal to 0.00125 moles. Determine the number of moles of the acid in 100 centimeter solution H. 100. Now we have the number of moles in this, in H14. This is the number of moles. This moles is in this. We will ask what about 100. So 14.07 centimeters cube solution H contains 0.00125 moles. What about 100 centimeters cube of H? So it is 100 times this divided by this. This one will give you 0.008884 moles. So moles in 100 of solution H contains this. Determine the number of moles in 20 centimeters of solution G. 20. Yes. Up here now, I want you to understand this, although I have explained earlier. 20, the number of moles in 100 centimeters cube solution H will be equal to number of moles in 20 centimeters cube solution G. If you didn't get the way I explained, is that, remember, we measured 20 centimeters of G, added 80 centimeters cube of the distilled water, forming 100 centimeters cube solution H. So the number of moles in 100 centimeters cube solution H is equal to the number of moles in 20 centimeters cube of the original solution G. Moles does not, the number of moles does not change. What changes when you dilute a solution is the concentration. Therefore, moles in 20 centimeters cube solution G equal to the moles which is in 100, which is 0.00884 moles. This is the moles in 20 centimeters of solution G. Determine the number of moles in 250 centimeters cube of solution G. So we have in 20, what will be in 250? So 20 centimeters cube solution G contains 0.008884 moles. 250 centimeters cube solution G will contain which number of moles? So it is this times the 250 times 0.008884 divided by 20, which will give us 0.1111 moles. Right, next one is calculated the molar mass of the acid base, the molar mass of G. We want to calculate the molar mass of this. Molar mass is actually the same as RFM. Molar mass is the same as RFM. So we want to calculate the RFM. I want to do it to approach this one in two ways. You will pick the one which is easier, but the first one is going to be very simple. We know this. We know that moles is equal to mass over RFM. RFM is the same as molar mass. So if I want RFM, I have mass, I have moles. It is very simple. So RFM equal to mass divided by moles. I have mass in 250 centimeters cube. I have the number of moles in 250 centimeters cube of solution G. The number of moles are here. The mass are on the other side. The mass are here. Solution B was dissolved 23.46 grams. I have the mass in 250. That one I will do directly. Therefore, 23.46 divided by a number of moles, which is 0.111. This one will give you 211 grams. That is the RFM straight away. But we can also do it in a different way. Let me approach it using this triangle. Molarity, mass in grams per liter, and then RFM. So I can get RFM using mass in grams per liter. The mass we were given here is in 250. So we can get the mass in 1 liter. We will say 250 centimeters cube contains 23.46 grams. 1,000, that is mass in grams per liter. A liter will contain what? So this times this will give you 93.84 grams per liter. So now we have mass in grams per liter. What we don't have is molarity. We have the molarity, remember, is the number of moles in 1 liter. But the number of moles we have here is in 250. We can get now molarity. We will say 250 centimeters cube is the now contains 0.1111 moles. 1 liter a centimeter cube, because we want in molarity will contain what? So it is this times the which will give you 0.4444 capital M. That is molarity. Now that we have mass in grams per liter, we have molarity, we can now use the formula and say saying that RFM is equal to mass in grams per liter divided by molarity, which is equal mass in grams, which is 93.84 divided by 0.4444, which will give you 211. That's another way you can do it. Lastly, calculate the mass, or calculate the mass of M in the formula here. The mass. But we know when you add everything here, you get 211. So that one is easier for us to get M. H2 MO6, when you add everything, will give you 211. Hydrogen is, so 1 times 2, that's for hydrogen, plus M plus 16 times 6, which will give you 211. This is 2 plus M plus 96, which will give you 211. So like terms together, this one will give you 98 plus M is equal to 211. So like terms together again, M is equal to 211 minus 98. So M is equal to 113.